Good evening, guys. How you guys doing? Can you guys see can you guys see his screen? Can you guys see no sorry. Can you guys see his screen? How you guys doing? I can't see anything. Hey, you can't see anything here. Oh, just let me just put anything here. Okay, they can see it. That means it's your battery. It's your it's from your hand then. Don't worry, let me just put this there. Don't worry. They said it's not clear. No,
Someone says,
ca- you can see their comments now.
yeah, I can see the comment here.
Yeah, it's
I'm
using
getting a
system.
little clear.
Can you zoom it a bit?
Really? Is it
He said
really
it's
not?
far from this. It's far from the screen. Can you move your phone closer to? Fantastic.
Okay. But as it is like this now, can you see the whole computer? Can you see everything like
Yes, I
from
can see. I can just zoom it a bit. Then when you are writing, you'll be moving down. Do you get?
okay,
Zoom it closer a bit. Then when you're writing, you'll be just no. Zoom it closer a bit. Like when you're writing, you just be, so that the landscape. Then you'll be scrolling down, something like that.
okay. Can people see
uh
like this?
Yes, people can see. They can see.
Yes, it's okay, okay. I'm getting a lot of yeses. Okay. Alright, that's fine. Welcome, 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 welcome. We have 2 wonderful hours to spend together. Aren't you excited? We're learning about stoichiometry today. I hope you can see it very clearly.
Oh, sorry. Copy chemistry. Sorry. Let me just give a brief run through of who copy chemistry is. Okay. So, guys, good evening, everyone. As you can see, this copy chemistry is one of the top guys in the industry. Who is shaping the teaching space. As he teaches, I want you guys to subscribe to his channel. He's going to also drop. I will tell him to drop the name as he teaches. So, copy chemistry is the name on either on TikTok or YouTube. So I want you guys to subscribe to his channel. In fact, for future people that will still watch this, I'm saying this upfront. So he wants to teach us the scope of stoichiometry. He's the god of stoichiometry. As far as I'm concerned, I've seen his work and he's going to break it down for you guys. Okay, so have fun. Thank you so much. Yeah,
Interesting. Did you
yeah.
tell them about the gift though, for those who are staying to the end?
Yeah, definitely, definitely. And there's also a gift from him to you. So if you stay to the end of the video, he has sent me a gift I'm going to deliver to you. Okay. So yeah, have fun. Thank you.
Alright guys, alright. So this is wonderful, good stuff. You see that we have a lot in store for you. Abdusalam and Debbie says they already knew it was copy chemistry from the voice. Well, that's cool. That's cool. Interesting. Okay. So today we're going to be looking at two things. Yeah, we have 2 hours, remember. So we're going to be looking at stoichiometry, that's number one. And then we're also going to be looking at gas laws. Okay. We're also going to be looking at gas laws. So if you have there's this textbook, Lambda Chemistry, and I like that book because they are able to break things down into topic by topic, and then you see questions that fall under every topic. So we'd also be utilizing that and going through some of these questions. Okay, so the first one I have is, or actually, before I start solving questions, let me just tell you the basic things about stoichiometry. It's about proportion. Yeah, if five pence, if 5 pence cost 20 naira, what is the cost of 8 pence? Okay, so if you understand this one I'm doing right now, it means you're going to understand future things. If 5 pence costs 20 naira, 8 pence would cost X, and then I'll do a sort of cross multiplication here and dividing both sides. But this is just a shortcut, so you don't need to do all this stuff. You would say 8 times the thing across divided by the thing at the back. Okay, to figure out what x will be. 8 times the thing across, that's 20. 8 times 20 divided by the one at the back, 5. So that's just it. This guy gives me 4 here, and this guy gives me 32. So that's basically the answer. This looks like maths, right? You're going to see a lot of maths in chemistry. Okay, so that's it. Now, the common things you have to know is, number one, the fact that number of moles is equal to mass divided by molar mass. Okay, so that's one. Yeah. Also, you need to know that concentration is equal to number of moles divided by volume. So if you're writing, you can write number of moles of solute, the number of moles of solute divided by the volume of solution. So that is the concentration, also known as molarity. Molarity. Now the number of moles has to be in moles, obviously, right? And then the volume has to be in liters or dm cube. I hope I'm not too fast. Then you should take this down. 1000 cm cube is equal to 1 dm cube. Very important, because we'll be using that to convert back and forth, okay? So now that you know all these interesting things, I hope the 56 of you are ready for the next stage. Okay, I'm a little bit fast. Let me give you 1 minute to write this down. Okay, I'm going to allow you to write this down. And then let's talk about, the next thing, which is Avogadro's constant, because that's also another essential part. Avogadro's constant. The fact that 1 mole of a substance contains 6.022 times 10 to the 23. So that's how many atoms you have in 1 mole of a substance. That's also how many particles you have in 1 mole of a substance. That's also how many molecules you have in 1 mole of a substance. So it depends on how the question comes, actually, and then you would know. So please write that down. Let me just do a recap as you're writing. So a recap is that number of moles equals mass over molar mass, concentration is number of moles over volume, and that is the volume of the solution. Don't mix it up, guys. This is super important, that 1000 cm cube gives you 1 dm cube, and of course 1 mole equals 6.02 times 10 raised to the power 23 atoms. So that's really, really important. So someone says, are we going to do solubility? We don't even need to do solubility. Solubility is basically concentration. Concentration and solubility are the same. So if you remember this formula, then you are halfway done with solubility, okay? It's just going to be intuitive for you. Does that mean number of solute is moles? This n here is number of moles, but I'm trying to be specific to tell you that is the number of moles of solute that you're using, and then the unit of number of moles is moles. Is that clear? All right. So, having known this, it's now time to take some questions. Question number 1. Are you ready? If you're ready for question number 1, type 1 in the comments. Let me see those that are ready. Type 1. I want to confirm that you finished writing this. So type 1. Let me see if you're ready for question number 1. We're solving a few questions on stoichiometry, and these questions are JAMB related, of course. So if you see this in your exam Thursday, Friday, or Monday, or whichever day you're writing, you would know how to tackle them. So here's our question number 1. So question number 1 says, how many moles of calcium trioxocarbonate 4 How many moles of calcium trioxocarbonate 4 are there in 2.5 grams? This is 2.5 grams of calcium trioxocarbonate 4. And then you're given this, that calcium is equal to 12, oxygen is equal to 16, and then carbon equals 40. Okay? All right, let me solve it. Yes, I'm going to give you 1 minute to solve this question. 1 minute to solve this question. So go ahead. Let me see the first person that will get it. The first person that will get it, let me see. Oh, there are options. Let me write your options for you. Option A, 0.0025. Option B, 0.025. I give you options now. Are you sure people will not just guess? Okay, let me just write it here. And then D is 2.5. So the first response I'm getting here is from Adedayo Ajibola, and it says 0.025. We're going to find out. Please, CA is 40. Thank you for that. CA is actually 40, not 12. So this should be, I mixed it up. Interesting. CA is 40, you guys, and C is 12. At least we should know this one. So that's good. Thank you for pointing that out. Of course, you use what they give you in the exam. All right, but yeah, these are common things, so you should know. So how do you write calcium trioxocarbonate 4? That is CaCO3, okay? That is calcium trioxocarbonate 4. And the molar mass of this guy is going to be about 100 grams per mole when you calculate it. You know, sometimes if you have been playing with this thing here, some of these things will stick in your head already. 100 for CO2, carbon dioxide, is about 44, okay? So, but of course, you can always calculate it using this thing and do it slowly if you want. All right, so how many moles? Number of moles is mass divided by molar mass, right? So the mass is 2.5 and then the molar mass is 100. So you do that and 0.025, which is B, Aha, I've answered this question before in LandLab. Yes, this is actually LandLab. That's what we're using. So that is 1. So we solved question 1. I'm going to pull up another question here, which is going to be question 2 now. I see Debbie. Is this the Debbie that I know? Interesting. Okay. So this question says the number of hydrogen ions, I'll just write it this way because that is also hydrogen ions. The number of hydrogen ions in 9.8 grams of tetraoxosulfate 6 acid. Tetraoxosulfate 6 acid is what? Number of hydrogen ions present in 9.8 grams of tetraoxosulfate 6 acid. H2SO4, that's your tetraoxosulfate 6 acid. Hydrogen is equal to 1. Sulfur is about 32. Oxygen is about 16, Abby. Play with all these guys, you would already know that this one should be like 98 grams per mole. That's the molar mass of this guy. But you can do it slowly, right? Using all these things to know the actual molar mass. Okay, so now we're looking for the number of hydrogen ions, not number of moles of hydrogen ions. They're different things. Okay, we're looking for the number of hydrogen ions present in 9.8 grams of sulfuric acid, tetraoxosulfate 6 acid. So let me see answers, guys. How can we get molar mass? We would get molar mass by adding the relative atomic masses of what you have here. For instance, if you're to get the molar mass of H2SO4, it's going to be 2 of the hydrogen plus 1 of the sulfur plus 4 of the oxygen. Okay, so you calculate everything very well. You get 98 grams per mole. They ask you for molar mass, make sure you put the unit there, grams per mole. But if they ask you for the relative molecular mass, then it's just going to be 98 without a unit. Okay, so I'm seeing some answers there, and that's how you get that 98, by the way. All right, so some people have said giving answers. All right, so now let's do it together. The number of hydrogen ions, yeah, in 9.8 gram of sulfuric acid. So this is the first thing you need to do. You need to find out the difference between the sulfuric acid itself and hydrogen ion. Okay, when you dissociate this guy, you get this H plus and then SO42 minus. Yeah, and of course, to balance it, you would have that. It's very important that you balance it. You'll see why. So balancing it like this shows that 1 mole of H2SO4, in every 1 mole of H2SO4, you would have 2 moles of hydrogen ions there. Are you listening? So that would mean that if I should figure out the number of moles of sulfuric acid given to me in this question, I can know what the number of moles of hydrogen ions will be by proportion. Okay, so the first thing I need to do is to get my number of moles of my sulfuric acid using mass divided by molar mass. And that will just be 9.8 divided by 98. And what is that one? Is that 0.1? Please, we have calculators so we can confirm. Yes, so that's 0.1. So that would mean that the number of moles of H2SO4 is 0.1. Now, for every 1 mole of H2SO4, as you can see, you have 2 moles of hydrogen ion. So that would mean that this would translate to 0.2 moles of hydrogen ion. See that? So now that you have done this, it means that you have found that there actually exists 0.2 moles of hydrogen ions there. And then what do you do next? 1 mole of anything is usually equal to about 6.022 times 10 raised to the power 23 of the ions. Okay, so 1 mole of hydrogen ion is equal to that number of hydrogen ions itself. So now if you have 0.2, it's going to give you this times this divided by 1. So that just gives you 0.2 times 6.022 times 10 raised to the power 23. So let's do that. So that gives me, I hope you guys can see it too. So that will give me 1.204. Let me just write it here. 1.204 times 10 raised to the power 23 hydrogen ions. Okay, so that's what it will be. So that's what it's going to be. Now let me go back to see your answers. 1.24. So that's a Ramat 10 raised to the power 23. Yes, that's correct. So Naomi had 6.02. Samuel had 1.2. Let me see if I have other. So some people also had 0.602 times 10 raised to the power 24. So you see, this is where the disparity is. Some people might not remember to multiply by these two. You see that? You might not remember to multiply by the 2. And that will be a big problem. They're asking for the number of hydrogen ions. So first, it's coming from sulfuric acid. So you need to know the number of moles here first. Then you go ahead to get the number of ions themselves. Is this one hard, or is this one simple? Let me know. So you said, yes, that's my mistake. Yes, that's basically because I've been teaching a lot of students, right? I usually have a lot of people making that mistake. So please don't make it tomorrow or the day you're writing your jam. Don't make that mistake. Um, aren't we going to multiply it with basicity? Aren't we going to multiply with basicity? No, we're not. We're not. So please, I don't understand. Explain again. Can you use another question? Yes, I can use another question. Let's assume that you are dealing with HCl this time, and they ask you for the number of hydrogen ions in HCl. If it's HCl, yeah, this one is going to be really easy because HCl would break into this and this. So that will tell you that 1 mole of HCl will produce 1 mole of H plus. Okay, therefore, if you can calculate the number of moles of this one, you will know the number of moles of this, of the hydrogen ions. Then you now say 1 mole of hydrogen ion contains 6.02 times 10 to the 23 actual hydrogen ions. Then if you now have, 0.5 moles here, proportion, which is the very first thing I taught you from the beginning, and then you apply that and you've solved the question. Okay, so that is that one. Please, I have a question. By the way, if you have questions here, this is an opportunity for you. Put it in the comments. Put it in the comment if you have a question. If you have your own stoichiometry question, you can also bring it. You can put it in the comments, by the way. All right, so now we're going to try the next question. All right, so this one says, how many atoms of oxygen? So that's our next question now. How many atoms of oxygen are present in 8.8 grams of carbon 4 oxide? How many atoms of oxygen are present in 8.8 grams of carbon 4 oxide? So that's your question. How many atoms? Again, as you're hearing atoms, you know that you're going to use Avogadro somewhere in this question. Okay? So that's where it comes. So if your question is you don't understand, when Avogadro is used, I'm answering it now. When you hear atoms like this, you know that you're going to use Avogadro somewhere. But the way Avogadro works, if you go back to this place here, I wrote it down for you here. I said 1 mole is equal to this atoms. And I told you that it's not only atoms, it could be particles, molecules, ions, and all that. Okay? For that spot there. But it's equivalent to 1 mole of that thing. So you would need to relate moles and the particles. So now let's go back to this. How many atoms of oxygen are present in 8.8 grams of carbon dioxide? So you need to know how many moles of oxygen atoms are there to start with. Then you would relate it to Avogadro. So let me see your answers in the comments. How many atoms of oxygen are? This is a JAMB question. So try. So I have a 2.4. So somebody give an answer. 2.4 times 10 raised to the power 23. Okay, so I've seen one answer. Same answer with number 2. Alright, so let's solve this. I'm not seeing too many answers here, but I think Cast and Mujib, they're giving answers, and I think I like those answers. Alright, so let's work it out. How many atoms of oxygen are present in 8.8 grams of CO2? By the way, CO2 has a molar mass of about 44. If you have been here, I said it before, Abby. So CO2 is about 44 grams per mole. Let's figure out the number of moles of that. So number of moles is mass divided by molar mass. So it means that I'm talking about 8.8 divided by 44. And 8.8 divided by 44 should give me about 0.2. So that is the number of moles of CO2. Okay? It's just that for every CO2 that you have is like one carbon and two oxygen, Abby, or two atoms of oxygen. Yeah, so that means that you can see that for every 1 mole of CO2, there exists 2 moles of oxygen atom. You know, an atom is like super, super small, right? But when I say 2 moles of the oxygen atom, that's like the quantity of oxygen atom that I'm pulling out is 2 moles of oxygen atom. But that doesn't mean it's 2 oxygen atoms, okay? So this means that if I have 0.2 moles of CO2, I don't think you can see down there, so let me write it up here. So if I have 0.2 moles of CO2, it basically translates to 0.4 moles of oxygen atom. Okay? It said, but sir, is 1 mole. Yes, from here you may see it as 1 mole. This is 1 mole of O2, that's oxygen molecule. It's different from oxygen atom. Okay, for every 1 mole of O2, you get 2 moles of O, right? So even if you say it's 1 mole here, that's 1 mole of oxygen molecule. Or every 1 mole of oxygen molecule gives you 2 moles of oxygen atom. That's not 20, that's 2O. Right, so based on that, it will still translate to 2 moles of 0.2 moles of CO2 being 0.4 moles of oxygen atom. Okay, and from that, we know the number of moles of oxygen atom we have. Now, to finish it up, 1 mole of anything is supposed to be 6.022 atoms, times 10 raised to the power 23, by the way. So if you have 0.4 here, it's going to give you x, and you solve that very well, and your x becomes 0.4 times 6.022 times 10 raised to the power 23, which will give you about 2.41 times 10 raised to the power 23. So that is how to do it. Yeah, so let me write the answer at the top here. Try to write it with red and make it bold so you can see. That's the answer. So that is the number of atoms that you have in red there. Okay, so I have some comments here. On combustion, this of this gives da 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 da. What's the empirical formula? Okay, good question from Samuel. Let me see. But sir, is the oxygen that is diatomic on its own? No number is in front of that one. So it is 1. Yeah, oxygen is diatomic. Yes, it's 1. But that is oxygen molecule. Okay, O2 is oxygen molecule. That's what I explained before. So same explanation. All right. So this has been how to do this question. If you find a question on stoichiometry that is difficult, I'll advise that you should. If you can't figure it out in a few seconds, you could leave it and come back to it later. Usually the advice we get. All right. So are we ready for the next one? We're going to take Samuel's question on combustion of 0.0065 of organic compound. Da, 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 da. I'm coming. Just one moment. Okay, I'm still having someone asking how did I get 0.4? So that one is quite easy. From 0.2, you just multiply it by 2 because 1 mole of CO2 gives you 2 moles of oxygen atom. So 0.2 moles of CO2, which they gave us in the question, would translate to 0.4 moles of oxygen atom, okay? The question is from London. Good, go and check it there too. So you confirm the answers. Right, so the next thing we're going to be looking at is empirical formula. Empirical formula. Now you can do empirical formula questions from percentage composition. Are you listening? You can solve empirical formula questions from percentage composition, and you can also solve it from combustion analysis. So those are the two ways that you will probably learn at this level. You might not even learn combustion analysis at this level, so you might just learn the percentage thing. But I'm going to do the two here, okay? I'll do the two for you guys now. Okay, so the first thing you need to know here is that if you're solving empirical formula questions from percentage composition, then you should bear in mind the percentage compositions, that's number one, and also bear in mind the relative atomic masses, okay? So let me see if I can pull up a question that is on empirical formula calculation. Okay, so I've sent one. So this question says, let me call this question number 5. I don't know what question we are, but I'll just call it 5. So this question says,
Sorry, copy chemistry. Are you? Do you check the comment section? I think some people are saying some things. I can't hear them. Sorry, can you? Do you check the comment section?
yes, I can also see the comment section here.
Okay, I think
Uh,
some maybe some needs some clarification or some things I don't get. Which what are you
o-
get? What, maybe you can just check it. Yeah, thank you.
okay. Do we have a lot of people that don't really understand that? That was the last question we saw. Um, how do you figure out the moles? So if the question had been in molecules, it would have been 0.2 as the mole. Yes, yes. They're asking for the number of oxygen molecules or the number of oxygen molecules that's there. You'd be using 0.2 moles for that question. Let's just go back for the sake of those that didn't really get it. Okay, before we move forward, let's go back for their sake. So let's look at the question again. I'm going to take it from the top this time. So if you didn't get it, please listen. Please listen. I'm going to solve it now before we go ahead to empirical formula, okay? So we're going to take it from the top. How many atoms of oxygen are present in 8.8 grams of CO2? How many atoms of oxygen are present? Now, the first thing you want to do is to figure out the number of moles of your CO2 you're given, okay? This is the molar mass of CO2. The number of moles is this divided by this, and that's 0.2 moles of CO2. That's the very first thing you do. So let me assume that we are all on the same page now. I'm removing all these other things so you can see it clearly. Yeah, I hope we're together. Are we together right now? So now everybody understands how to get the number of moles of CO2 as 0.2. The other part of the screen should be removed, please. It's too reflective. Oh my god. I hope you can see. Okay. So, yeah, now we have the number of moles. Now we have the number of moles as 0.2 moles of CO2. This 44 grams per mole is the molar mass of CO2. And this is the number of moles of CO2. Okay, so if I'm to look for the of how many atoms of oxygen are present, yeah, this is CO2. Can you see that in 1 mole of CO2 you have 2 atoms of oxygen and 1 atom of carbon? Can you see it? Can you see that if this were CO2 and I draw it out like this, 1 molecule of CO2 like this, you would have 2 atoms of oxygen and 1 atom of carbon. Can we see that? On the screen with the marathon right up. Oh, is that what you mean? Okay, just try to focus. Let me see if I can increase the brightness of this for your sake. To only kill my battery faster, but I hope it's a help. Okay, right. So when you have this now, the next thing to do is to figure out that in 1 molecule of CO2, you'd have 2 atoms of oxygen. So that would mean that if 1 mole of CO2 has 2 moles of oxygen atom, has 2 moles of oxygen atom. Okay, and you can actually see that because inside 1 molecule, this is a molecule what I've circled, that's a molecule of CO2. Inside 1 molecule, you have 2 atoms of CO. Okay, so you can easily picture that out. So from here, we now said 0.2 moles, 0.2 moles here of CO2 would contain a particular amount of moles of oxygen atoms. Okay, and based on that, our x became 0.2 times 2, which is 0.4. So 0.4 is the moles of oxygen atom. So that is moles of oxygen atom. Now, 1 mole of oxygen atom is actually going to contain 6.022 times 10 raised to the power 23 actual oxygen atoms. Okay, so the 0.4 that you now have of your oxygen atom would then be 0.4 times 6.02 times 10 raised to the power 23. You solve that and you get what you have up here. So that's how it is done. That's how it is done. That's how it is done. Yeah, and actually some people got this, at the beginning. So that means somebody understands. But you guys that didn't understand before, how is it now? Is it better? Is it better now? Okay, Naomi says it's better. Abdusalam, remember we have 2 hours, guys. So make sure you gain something. Make sure you gain something. Okay. So yeah, let's check out the question on empirical formula. Got it now. They are very happy now. They are very happy. Okay. So yeah, what is the empirical formula? What is the empirical formula of an organic compound containing 40% containing 40% carbon and 6.67% hydrogen by mass. Okay, and then they'll tell you that carbon is equal to 12 and hydrogen is equal to 1. Right, so what is the empirical formula of an organic compound containing 40% of carbon and 6.67% of hydrogen by mass? Again, they might just give you 40 grams and then this one in grams. They might not give you percent, but you solve it the same way. Okay, so I already have answers here. CH2. So some people are already getting the answers for this one. Can you define empirical formula? Empirical formula is the simplest formula of a compound. Okay, it contains the atom in simple whole number ratio. That's your empirical formula. Is it solving Samuel questions? Not yet. That's what I'll do after this. So this is the simple one. And now this is how to solve it. I'm seeing answers, so let's tackle it. So the first thing you want to do is you write your carbon here and you write your hydrogen here, Abby. Pretty simple. Then you'd have 40%. So I'm going to write 40 there. Can you see that green ink? Let me use blue. And then hydrogen is what? 6.67. Okay. So that is the first thing you want to do. This is 40. This is 6.67. If you add it up, it doesn't give you 100. So you know. Because this one I'm just seeing everybody writing CH2 there. Are you sure there's no oxygen inside? Question. JAMB question. Think they'll be so happy with you to just give you like this. This is 40%. This is 6.6. Okay. So that means that it doesn't add up to 100. It just gives you like 46. So there is still something that's inside here for the remaining whatever percent. Now let us find that out. The first thing you need to do is to check whether it will add up to 100. Okay, so that's the first thing. 40 plus 6.67 will give you 46.67, and when you do 100 minus that, you would know the remaining thing. So that means we have 53.3% of something else. Most times it's usually oxygen. So let's add it here. 53.3, okay? And then we'll try to solve that. By the way, they also wrote oxygen in this place. They wrote oxygen as 16 in the question. So that's also a clue to tell you that, something should be added there. Now, we'll do it the same way you have been doing it. Hmm? Don't worry, Naomi, it's JAMB. It must be tricky. Some people might ignore this one now and they'll start solving it only this. Failure! Alright, so let's divide, guys. Let's divide. 40 divided by 12, what does that give us? So we're now 86, that's cool. Welcome. And then this is 6.67, right? Do the other one, and then you have 53.3 divided by 16, and that gives you 3.33 as well, right? Now the next thing to do after dividing by the relative atomic masses, and you've gotten these numbers, the next thing to do is to divide through by the smallest value, which is going to be 3.33. So you divide by 3.33 over, and if you do that very well, you're going to get 1 ratio 2 ratio 1. Okay, so that would mean that your empirical formula would be C1, which you don't actually need to write, H2, and then O1, which you don't actually need to write. So that's just CH2O. So that is your empirical formula, CH2O. I'm going to leave it like this for a while and let me know if this is clear to you. CH2O from Favor. Yes. Yes. So that is your answer. And that's how to do it. So make sure, I know you guys already know that you divide this, yeah, but don't forget this. So that's one thing I'll tell you. The next thing I'm going to tell you in empirical formula is when you are doing your thing and you do your division, yeah, this one it was very clean. I had 1:2:1. That's because when I divided 6.67 divided by 3.33 on the calculator, I had 2.003. That's what I had, 2.00. Okay, 2.00. Now, if you have this, if I have 2.0, 2.1, 2.2, 2.3, 2.4, 2.5, 2.6, 2.7, 2.8, 2.9, and 3.0. Okay, these are the things you may see. Yeah, it may not be 2, it may be 5.0, 5.1, that kind of thing. That's what you get at this point here. Here. This one, luckily for me, it was 2.003. So that's like a 2.0. Now I'm telling you that, you see this stuff here, you might get them at this point here, but you have to leave your answer in a whole number ratio. Why are you people calling me right now? You can't call me now. Call me anytime, not now. Don't understand. Okay, so what I'm saying is, if you have 2.0, you can round it down. Yeah, you can round it down. If you have 2.1, you can round it down. If you have 2.2, you can round it down. So I have a question here. It says, sir, you mean if the sum of the two percentage isn't equal to 100, we should remove it from 100? Yes, that's what we did here. Exactly. We added this two, gave us 46. So we know that there's still something left. It must be 100% in total. So we have to find out what that was. And that's 53.3. By adding this and then subtracting it from 100, you will know what's left. So what am I saying here, guys? I said if you have something like this, 2.0, 2.1, 2.2, you can round it down to 2, okay? Now, if you have this one here, 2.8, 2.9, 3.0, you can round this one up to 3, okay? But if you have 0.4, 0.4, 0.5, 0.6, okay, let's allow you to do this at this level. Let's allow you to add this one to it. But you see that 0.5, 0.4, and 0.6, you don't round it to, you don't round it. Please be very attentive. You don't round it. If you have 2.4, 2.5, and 2. Let's say, for instance, I have carbon and hydrogen, right? And then I have 1:2.5. You don't say this means is 1:3, and then you say your answer is CH3. That's wrong. That's very, very wrong. And that's why you came for this class today, so that you learn. What you're supposed to do here is this 2.5 is actually the same thing as 5/2. And then when you make it a whole number ratio by multiplying through by 2, you're going to have 2:5. And that would mean that the empirical formula would now be C2H5. So this is the correct thing. The CH3 is wrong. I hope you I hope you are looking at this thing very well. So you don't round up 0.5, you don't round up 0.4, you don't round up zero point 0.6, you don't round down zero point 0.4, you don't round up 0.5, and you don't round up 0.6. It's not maths, it's chemistry. In maths, they told you can round. Yes. Here, you will fail if you round. I'm telling you. Okay, so please take note of that. you will multiply. So if it were 2.4 now, if this was 1:2.4, you have to multiply both of them by a particular number that you can now round. For instance, if it's 1:2.4 and I multiply both of them by 2, this gives me 2:4.8, Abby. Am I allowed to round 4.8? Yes, I can round a 0.8, so that gives me 2:5 eventually. So please take note of that. That's what you do. So let me check the comments now. I think, must have had some question. I'm late for the class, Michael. Welcome. We're just starting. Um, yes, it's percentage. I thought 6 can be rounded. That's maths. I've told you what I told you here. Please write it down. Does molecular mass equal vapor density divided by 2 or multiplied by 2? Molecular mass equals vapor density multiplied by 2. So I hope I've answered that, Naomi. It helps you, yes, when you want to get molecular formula. So you need to go back and watch some videos. Some of these videos are on the chemistry tutors page. They're also on my page about solving questions like this. So please go back and watch those videos. It will really help. Let me see. Does it mean the percentage composition must equal 100 for any given compound? Yes, it must. It would mean that something is missing if it doesn't equal 100. Okay, yes, so I've been able to answer this question. Samuel, are you still here? Let's treat Samuel's question. Samuel's question is on combustion analysis. Samuel, if you can please send the question again so that it appears at the bottom. Okay, I've seen it. I've seen it. So, guys, if you're still here, 75 of you, if you scroll up, you'll see Samuel's question here. I'm going to write it on the board. On combustion, 0.0065 grams of an organic compound containing CH and N. CH and N only. Okay, CH and N, that's strange. Thought it would be CH and O. CH and N only yielded 0.0146 of CO2 and 0.0089 of H2O. What is the empirical formula of the compound? What is the empirical formula of the compound? So this is calculation of empirical formula using combustion analysis. And here, now one thing that really struck me in this question is the fact that it said N, right? CH and N only. I was also expecting CH and O only, yeah? But that doesn't mean this will not work. This will still work, still possible. All right, so I've taken that one. Can we round 2.6? So somebody asked a question from there. 2.5, 2.4, 2.6, you cannot round it. Maybe you take a screenshot of this page so you always see it. So what if it's 2.4? You cannot round all these ones I circled in red. So I repeat the range we can approximate. This is it. Snap this guy. Okay. So Don Skit. So Don Skit also has a question there that looks like what we've done before. So basically, that question can also be analyzed the same way and solved very easy. So, but yeah, let's do this. Let's do this. This one we've not done it before. On combustion, this gram of the organic compound containing this, and this only yielded this amount of CO2, right? And this amount of H2O. This is what you're going to do. The first thing you would need to do is to say the carbon that is present in this compound here, all of them formed CO2. Okay, so the amount of carbon in CO2 is going to be 12, that is carbon itself, over CO2 times, the total mass of CO2 that you have. Okay, times the total mass of CO2. What I just did there, if you look at that small thing I wrote there, what I just did is telling you the fraction of C in CO2. Yeah, when you multiply it by the mass of CO2, you will get the mass of carbon. So if you want to get mass of carbon in CO2, it's going to be 12 divided by 44 times the mass of CO2, which is this 0.0146. So somebody should solve that one and let me know. Also, all the oxygen, or rather all the hydrogen rather, in this compound came out as H2O. Again, to find out the amount of hydrogen in the H2O is going to be 2 hydrogen divided by H2O, then you multiply it by the amount of water that you have in the question, which is this. I hope you're listening. This time around, I'm using 2H here because in one H2O, you have 2 hydrogen inside. So 2 hydrogen divided by all the H2O times this. So that's basically going to be 2 times 1 divided by the whole of this will give you about 18. I don't know if you can see that part, so let me just write it up. So that will be 2 divided by 18 times 0.0089. So another person should solve that one and let me know. Said my screen is not clear. Is that true? Is that true? Is that true? Can you see it now? I can't see the chemistry tutor here. But can you see my screen though? No, it's clear. Abdul Salam says it's clear. So it is clear. And it's even a little larger. My screen is clear. Okay, so yeah. Are we solving that thing? 0.0039. Okay, let's see. Let me do the first one. 12 over 44 times 0.0146. I hope somewhere is in here. Or somewhere, if you're in here, please let me know. You're the one that asked this question. And this is also an important JAMB question. So that's good. And then for the other one, 2 over 18 is 1 over 9, right? So 0.0089 divided by 9.